Hello? Yeah, all right. Let's get started. I apologize for my my formal dress. This is not what I usually wear at 11:40 in the night, but I figured my company is called Polo Tutoring Company, so it would only be fair to give you the same treatment as my students. So, logarithms. A logarithm is something in math that was basically invented, right? It's not something like addition or subtraction where it's kind of a natural process where it makes sense, like, oh, 1 plus 1 equals 2, or 2 plus 2 equals 3, or, I have one cow, I have another cow, I have two cows, or, something like that process. Mathematicians basically invented the logarithm because they wanted to be able to solve a certain set of equations. And those equations have the format, I hope you can see this. It might be backwards, and if that's the case, I apologize, but it is the format A to the B is equal to C, right? A, a random number, a natural number, to some exponent is equal to something, right? And what mathematicians had trouble with was finding out what exactly the exponent was supposed to be, right? For example, 2 to the what power equals 16. You and I both know that's 4, but, say it's 2 to the some power equals, 512. It gets progressively harder, and there needed to be some way of kind of making it an explicit general form to the solutions of those types of equations. So the way they did that was just basically creating an operation that you can use on your calculator. I'll be right back. It's right here. If you press this log button right there, it should be pretty easy to find on any TI-84. And I think they have on TI-85 plus, I'm nearly certain, but basically, well, the log button on the calculator is the common log, but we'll get into that in a second. Basically, log base something, we'll call it A, of B, right? I'll look that up again. I really hope that's not backwards for you. That'd be a real shame, but log A of B is basically, it's a question. It's not a formula. It's saying A to the what power is equal to B. And so let's give it an example. Like I said earlier, log base 2 of 16. Well, that's equal to, 2 to the 4th power is equal to 16. So that is equal to, that's equal to 4. And the reason why logarithms are so useful is because we're able to include them in answers, right? Instead of having to say, a certain number is, instead of having to really solve for a number that might go into the millions and millions of decimal places, right? You could just, put it in logarithmic form, which is very concise, neat, readable by anyone. And yeah, it's incredibly useful. Now transitioning into a subset of logarithms, it's called the natural log. A natural log is basically it's the same as a normal logarithm, except its log is the base of, the base of the log is a mathematical constant e, and e is an incredibly famous mathematical constant up there with pi, the golden ratio, those sorts of things. It's approximately 2.7128, I think. I don't know, give or take a couple hundredths, but it's incredibly useful in calculus, but that's not what we're doing right now. We just need to introduce the constant itself. For this level of mathematics, you won't really need to do so much with the value of e other than, using it as itself, as a letter. So let's say we have log base e of some number, I guess 10, right? Log base e of 10 is saying e to the what power is 10, and that's going to be somewhat around, I don't know, 3, a little bit less than 3. A little bit more than 2, a little bit less than 3, so somewhere in there. But that's not important. Sorry, I get sidetracked. And what we call ln, the natural log. So log base e of 10 could be written as just ln n, or ln 10, sorry. Right, so if, like I said, this isn't backwards, log e to the base of 10 and ln 10, oh, I forgot my closed parentheses right there, imagine that's there, are the same thing. It's just different ways of writing it. That can be useful in solving equations, like this one. The practice problem you gave me was 400 over 1 plus e to the x is equal to 350. And so how would we solve that as an equation? Well, you can, get a pen and notepad and do this up alongside me. The way I would solve it is, I'm sorry I'm not going to be able to get a great video of this. I can send you a picture of my work afterwards if you need, or I can try my best to get it on video here, but I don't know if the perspective is going to reverse it. So we have 400 over 1 plus e to the negative x equals 350. And e to the negative x is the same as saying 1 over e to the x. So if we want to multiply both sides by the denominator, which is 1 plus e to the negative x, we get 400 equals 350 times 1 plus e to the negative x. Well, then we can distribute on that right side, and we can get 350 plus 350 times e to the negative x. All right? And so we get 400 equals 350 plus 350 times e to the negative x. Now, if we wanted to isolate the e, which in this case we want to do because we want to eventually solve for x, and that's connected to the e, we're going to subtract 350 from both sides, and we'll get 50 is equal to 350 times e to the negative x. Well, then what's the next step in terms of isolating e? Division. We have to divide by 350. We get 50 divided by 350 equals e to the negative x. And we can simplify that to 1 over 7 is equal to e to the negative x. And so what we've ended on is e to the negative x is equal to 1/7. Now that might sound really, really complicated, but in essence, it's the same as saying 2 to the what power is equal to 16, which is a much simpler problem. And so we can kind of use the same logic and say, what exponent is equal to, when e is raised to the power of some exponent, what does that exponent have to be in order for it to be 1/7? Well, the result. Well, that result would be log base e of 1/7, or ln of 1/7. Okay, but we're not done yet. The reason we're not done yet is because, we just solved for the exponent above the e, which is negative x. It's not just x. It's not e to the x is equal to 1/7. It's e to the negative x is equal to 1/7. So in order to compensate for that, we're going to have to negate it, and we'll get negative x is equal to negative ln of 1 over 7. And because of a property of logs, we can actually, raise that exponent up to, raise that negation, or the coefficient of -1, and use that instead as a power of the number inside the parenthetical, which is 1 over 7. And we get x is equal to the ln of 1/7 to the -1, which means that we just have to flip it around, take the reciprocal, and we end up getting x is equal to ln of 7. So all of this whole complex equation and all of this mathematics has simplified down to a relatively simple form of x is equal to ln 7. And if you can try to, if this doesn't show up, I'm going to be really upset with myself, but I hope it does. And if it does, you can somewhat see my process, and I hope it makes somewhat sense to you. It's hard to kind of project without any sort of response, because I can't really, ask you, does this make sense? And then you can say yes or no, and then I can, do that. I kind of just have to go through assuming that you've kind of caught this stuff. But if you have any questions, you can just text me about it. Let's see, what else can I go over? Oh, the common log. The common log, which is used in your calculator. It's log, that thing. That is, well, you'll notice that when you press the log button on your calculator, it's not going to have a base. It's just going to say log, open parentheses. That's assuming that you're doing log base 10, right? So log base, if you put log 100, for instance, you're going to get 2, because 10 to the power of 2 is 100. Now, you might be asking yourself, or you might not, but if you are, and I hope you are, how do I get, customized bases? Like, what if a problem's asking me for the log base 3 of a number, and I don't know how to do that? Well, in order for that to happen, you're going to need some, you're going to need to use the base substitution formula, which, if I can Google that just to make sure I'm not making a mistake, it should be division of logs. It should be, yes, okay. So the base substitution formula is log base b of a is equal to log base x of a over log base x of b. And that might sound like a load of garbage, and in some ways it is, but let's try and make sense of it. So log base b of a, which is, like log base 2 of 16, or, any of these other things that we've talked about, log base e of 7 or something like that, is equal to the log of any number x, right? And that can be any number, of the thing inside the parenthetical divided by the log of that same number x of the base of the original log. And so the way we can get customized formulas on our calculator is we can say, if we wanted log base a of b, we can do log base b divided by log base a. And because both of those log parentheses is log base 10, that 10 serves as our x. And you'll notice something really interesting. If you do, if you try this out, right? Log base 100 over log base, let's see. Log base 97 divided by log base 65. Those are just two random numbers that I thought of. That's 1.095. Quite a random number, right? Now, what if you used ln? ln of 97 divided by ln of 65. Well, before I press enter, I just want to think about what could happen. Well, all that we're changing is we're changing the 10 in the base of each log to an e in the base of each log. But the base substitution formula doesn't need a difference, or doesn't show any difference between any different values of the base. So theoretically, they should be equal. And when I press enter, they actually are equal. You find that they are the exact same value, 1.09589, which is something I find really fascinating about logs. I might just be a nerd, but let's see. Is there anything I can go over quickly? I don't know. Yeah, if you need my work, I can send you a photo of that. I hope this helps. If it hasn't, I'm sorry for wasting 15 minutes of your time. Um, but yeah, let me know if you have any issues.